Hello, my dear students. This is Mrs. Shaimah Gharib and today's lesson about 3D shapes, nets of the cube. Let's start by revising some rules before you watch any video. First, you have to sit in a quiet place. You should have your pen and a piece of paper to take notes and to solve questions. You should pause the video after each question, then you try to answer on your own. Then you play the video to check your answer and to understand the question in case you get a wrong answer. Are you ready? Let's start. What are the names of the following shapes? Here are some solids or 3D shapes. Let's start by the first one. It's called cube. And the second one is called cuboid or rectangular prism. And the third one here is cylinder. And this one is triangular prism. And this one is squared based pyramid. And the last one here is triangular based pyramid, and we can also call it tetrahedron. The net shape. What is the net shape? It is a figure which can be folded to form a solid or to form a 3D shapes. As you can see, if we folded these shapes along their sides here, we are going to form a 3D shape. In this video, we are going to talk about the cube. First, let's revise some important properties about the cube. Here it is. This is a cube. Let's complete these sentences. The cube has how many faces? Do you remember? How many faces does the cube have? This is a face. So this is 1. So all the faces in the cube are 6 faces. All of them are. What is the shape of this face? In the cube, all faces are squares. So the cube has 6 faces and all of them are squares. The cube has how many edges? And what the meaning of the edge is the side here. The line of the cubes. So how many edges does the cube have? If you count on the edges of the cube, you will find there are 12 edges in the cube. And what about the vertices? The vertices means the corners. When edges meet, the edges meet at a corner. So we can say that this is the corner and this is another corner, okay, or vertex. So how many vertices in total in the cube? We have 4 up and 4 down in the base. So there are 8 vertices in the cube. Now I will show you a video about the net of the cube.
Let's take a cube and dissect it. We will keep this one as the reference. Take another cube exactly like this one and dissect it. By dissect, I mean that we will open the cube up along its edges. And what will we get if we open it up? Let's see. We can open the top face first. This looks like a box with its top face open. Then we can open the green face in the front. Then we drop the orange and the blue faces on the right. The faces that remain are the face to the left and the face behind. Next, we can drop the left face to the left, and then we drop the only remaining face behind. Now we have completely opened up the cube along its edges to get a 2-dimensional shape like this. But what is this? What is it called? This is called the net of the solid. In this case, it's the net of a cube. A net is a diagram which shows what the solid will look like when it is opened along its edges and laid flat. The net, as we can see, is clearly 2-dimensional. If we look at it from the top, it will look like this. The orange face is the face to the right, the blue face is the top face, the green face is the face in the front, the black face is the base, the purple one was on the one at the back, and the red one was on the left. Yes, all we did was open up the faces along the edges and we got the net of a solid. Now listen to the next question carefully. Does the net of this solid have to look exactly like this? Is this the only possible net of the cube? Maybe not. Let's see if we can open up the same cube differently. We open up the top face first along this edge. Then we open up the front face outwards towards the right. Then we make the side face fall towards the right. There are still two faces remaining, the purple one at the back and the red one to the left. So we drop the left face towards the left and the back face backwards. This is what we get. It's clearly different from the earlier one. To know how it's different, let's look at the top view. The top view will look like this. So drawing the net of a solid may result in different figures. It doesn't have to be the same.
Now, after this video, we are going to talk about all the possible nets of the cube. Here is the cube, and we know that all the faces are squares, and the number of faces of the cube is 6 faces. Actually, there are 11 possible nets for the cube. Look at these shapes here. All of them are possible nets for the cube. All of them have 6 faces, 6 square faces in different patterns, as you can see. It's really important to know the 11 possible nets of the cube. Try to draw them on your own and to remember all the 11 possible nets. Okay? Opposite faces of the cube. Now we are going to talk about how to identify the opposite faces when I have the net shape of the cube. For example, this shape is one of the possible nets of the cube. I gave the opposite faces the same letter and color. For example, S and S for opposite faces, F and F opposite faces, B and B opposite faces. So how to identify the opposite faces if I don't have these letters? First of all, I want all of you to start identifying from the column or the row that has 3 or 4 squares. For example, this row, as you can see, it has 3 squares, and this column has 4 squares. So we can start from any of them. For example, if I started from the row that has 3 squares, I will choose these 2 faces. Why? Because opposite faces should not meet at a point or at an edge. So look at this square and this square. They don't meet. They have a face in between, another face in between. So they are opposite faces. Also for these 4 faces, this face is opposite to this face because they don't meet at a point or at a line or edge. For example, look at these 2 faces, this F and this S. They meet at this side, so they are not opposite to each other. They cannot be opposite to each other. Look at this face, the B, this one, cannot be opposite to this one because they meet at an edge. It cannot be opposite to this one because both of them meet at this point. Can you see this point, the meeting point between them? So they cannot be opposite faces. And also this face and the other one here cannot be opposite because they meet at a point. So to identify opposite faces, we have to know that opposite faces never meet at a point or a side or an edge. Is it clear? So let's see another one. In this one, I don't have any 3 squares in any of the rows, but I have 4 squares here in the same column. So I will start identifying the opposite faces from this column by choosing the faces that don't meet at a point or a side. Is this clear? So if I started from this column, I will say that this face is opposite to this one, and this one is the opposite of this one, which means these 2 are opposite to each other. I will do exactly the same with this one and this one and this one. I have here 3. I have here 3. I can start from any of them. I have here 4, a column with with 4 faces. Same here, I have a column that has 4 faces. Same here, I have a column with 4 faces. Here I have a column with 3 faces, so I can start with it. Now, this one also has a column that has 3 faces, so I can say this one is opposite to this one. What about the others? What should I do next? I will look at the one in the middle and I will think, could this face be opposite to this one? No, they meet at a point. Could this face be opposite to this one? No, because they meet at this point here. Which means this one is the opposite face of this face up here. Which means the last two here are opposite to each other. Is this clear? So we always find the start. We always start from the column or the row that has 3 or 4 faces. Now, look at this net. We don't have any 3 faces in a row or in a column, or 4 faces in a row or in a column. So where to start? If I look at this face here, look at this face, could it be opposite to this one? No, because they meet at this point. And also it's not the opposite of this one. They meet at a side. And it's not opposite to this one because they meet at a side. And not opposite to this one because they meet at a point. Which means the opposite face of this one is this one down here. After identifying these 2 faces, I will think of the other faces. Look at the one under it here. Could it be opposite to this one? No, they meet at a side. Could it be opposite to this one? No, they meet at a point, which means the opposite face or the opposite for this face is the one on top here, leaving these 2 faces opposite to each other at the end. Is this now clear how to identify opposite faces in a net of a cube? Look at this one here. It has 3 and 3, 2 columns, so it's easy to identify the opposite faces. Okay? Now let's answer some questions. Look at this question here. Here is a 3 times 3 solid cube made of blocks. As you can see, this is a cube that made from small cubes. A 3 times 3 means the base of this cube is 3 centimeters or 3 cubes and 3 cubes length and 3 cubes width. If we painted all this cube from the outside with blue, so we have this cube, imagine the problem. We are going to paint it from the outside with blue. The first question is, how many small cubes of these cubes will have 3 blue faces? I will ask you a question here. Look at this small cube here. How many faces of this cube you can see? I can see the face on top and I can see this face. So I only see 2 of its faces. What about the one in the corner here? I can see the top face and the front face and the face on the side. So I can see 3 of this cube, 3 faces of this small cube here. So this one will have 3 blue faces. If I paint the big cube with blue, this small cube here will be covered by blue. 3 faces of it will be covered by blue. Can you see or can you find any other small cube in this big cube that will be covered three faces of it will be covered by blue? Yes, the corners, all the cubes in the corners of the big cube will be covered by blue, will have three faces covered by blue. So I have a corner here and a corner at the back here and one at the back here and one and this one and the four down, the four corners down. So how many small cubes at the end will have three blue faces? 8 cubes. The four corners on top and the four corners at the bottom. Is this clear? The second question. How many small cubes will have two blue faces? Do you remember the first example? Which of these cubes? We can see two faces of them, only two faces. So look at this one here. I can see the face on top and the face in the front here. Can we have any other cube with the same features? Yes. Can you see this one in the middle? I can see the top and the side view of it. So I can see two faces. So it has two faces that will be painted with blue. Can you find how many of these cubes are inside this big cube? Yes, we can say that this one and the one opposite to it here, and this one and the one opposite to it here. So I have in the first layer of this cube, I have 4 small cubes. What about the second layer of the cube? Can you see this one? I can see only two faces, this face, the front face, and the face on the side. And this one as well, and this one, and the one behind. So another 4 in the second layer. And what about the layer at the bottom? Same ones as the first layer. So I have 4 in the first layer. I have 4 in the second layer. I have 4 in the third layer at the bottom. So in total, I have 12 cubes that have 2 blue faces. The last question, how many small cubes will have 1 blue face? Let's check all the cubes we have. We checked these. Let's look at the first layer here. We said the 4 corners have 3 faces, 3 blue faces. And we said the ones in the middle, the 4 ones in the middle, here have 2 faces, 2 blue faces. So which one? The only one exactly in the middle here, that the one that has only 1 blue face, because I can only see one face of it. Can you see it? The one in the middle. I have another one in the middle here, and I have another one in the middle here. So in each face of the cube, I have one in the middle that have 1 blue face, which means in total I have 6 cubes that have 1 blue face. Now let's find the missing cubes in some cubes. First, I will start with this cube here. As you can see, how many small cubes are there in this big cube? As we said before, the cube has layers. It consists from small cubes, as you can see. So the first layer looks like this. It has how many small cubes in the first layer? 3 and 3 and 3, 9. And another layer in the middle, which has same number of cubes, 9 cubes. And the layer on top, same exactly, it has another 9 small cubes. So when I place these 3 layers on each other, it will form this big cube. So how many small cubes in total? 9 and 9 and 9, which is 27. I can also calculate the number of cubes in any cube using the volume rule. Do you remember the volume of the cube? If you don't remember the volume of the cube, you can watch the video of volume and capacity. And now we will have a quick revision on the volume. Volume of the cube equals length times width times height. What is the length and what is the width and what is the height? So this is the length and the width and this is the height. And in the cube we said all of them are equal to each other because all the sides of the cube has the same length. So for example, what is the length of this cube? Look at the length of its side. So the side here has 3 small cubes, so the length is 3. And the width equal to the length. Look at the width here. It has 3 also, of course, because this is a cube. And what about the height? It has 3 cubes also, because we said before that the length equal to the width equal to the height in the cube. So I will just multiply the 3 times 3 times 3. The 3 times itself 3 times, which means 3 cubed. Do you remember? What is 3 cubed? 3 cubed is 27. So I can use this rule also to calculate the volume of the cube, or how many small cubes are there in the cube, by cubing 3, which is the side length, times itself 3 times, or 3 cubed to the power of 3, which is 27 as well. 3 times 3 times 3. 3 times 3, 9. 9 times 3, 27. Now look at this question. I have a cube here with some missing cubes. The question is, how many small cubes are needed to complete this big cube? So let's do it and try to complete this cube one by one. I will place this here. 1, 2, 3, 4, 5. So I can look at the shape and try to find out how many cubes are missing. In this case, we need 5 small cubes to complete the big cube. Is this clear? Now let's see more examples. Write down the smallest number of unit cubes that must be added to these shapes to make cubes. Look at this shape. It has missing number of cubes. It's not a cube. I need the smallest number of small cubes that complete this shape. This shape is very easy and simple. We can say that all sides are equal here. Let's check the sides. Look at this, 2 cubes, and the width 2, and the height is 2. So the missing number of cubes is only 1 cube. What if I have a complicated shape with larger number of cubes and larger number of missing cubes? How should I think? First of all, I have to identify the length and width of the cube, and remember the volume of the cube. I have to use the volume of the cube rule. Let's remember together the volume of the cube. Here it is, the cube. We said this is the length, this is the width, and this is the height of the cube. And we said to calculate the volume of the cube, we multiply the length times width times height. So first step, I will identify the longest side of the shape. All the sides here has 2 cubes, so it's number 2. So the longest side here is 2 squares. Second step, I will calculate the volume. So now I know the side. The side length is 2, and I always choose the longest side in the drawing. So if the side length is 2, then the volume will be 2 times 2 times 2, which is 8. So the volume of this cube is 8. Do I have 8 cubes in this photo, in this shape? No. So how many cubes are there in this photo? I have 4 at the bottom and 3 on top. So I only have 7 cubes. So how many cubes are missing to complete to the volume? The 7 to be 8, I only need 1 cube. I will subtract the number of cubes in the photo or in the drawing from the volume of the cube. Now look at the second photo here. I have another shape that has missing cubes. I need to complete it to be a cube. What is the side length? Any side or the longest side? All the sides here are the same. I have 3. I have 3. So the longest side here is 3. What is the next step? Find the volume. If the side is 3, how to find the volume? The 3 times itself 3 times or cubed. 3 times 3 times 3, which is 27. So this is the volume. What is the last step? Find how many cubes you can see in this shape, or how many cubes are there in this shape. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 cubes in this shape. So how many cubes are missing? I will subtract the 8 from the 27. So 27 minus 8 equals 19. So I need 19 more cubes to complete this shape to be a cube. Now look at the last one. We're going to follow the same steps exactly. Identify the longest side. I have here 2 and I have in this side 4. So which one is the longest side? The 4. So the longest side here is 4. What is the next step? Calculate the volume. If the side is 4, then the volume will be 4 times 4 times 4, which is 64. What is the last step? I will find out how many small cubes are there in this shape. How many small cubes in this shape? As you can see, 1, 2, 3, 4, 1, 2, 3, 4. Then we have 8 small cubes. And to find the answer or the number of missing cubes, I'm going to subtract the 8, the number in the photo, from the volume. So 64 minus 8 equals 56. So the answer is I need 56 small cubes to complete this shape to be a cube. Is this clear? Now look at this question. The following nets show the nets of a cube without a lid. What does it mean? We know that the net of any cube has 6 faces. If the cube has no lid, it means its net will have only 5 faces. What we should do here? Take the base of each cube. How to know the base of the cube with no lid? Imagine a cube that has no lid and look at its base. The base has no opposite face because the opposite face of the base is the lid, and we said the cube has no lid. So I need to find which of these faces has no opposite face. We said to identify the opposite faces, we are going to do what? Start from the column or the side that has 3 or 4 squares. I have a row here that has 3 squares. Then this face is opposite to this face. Now look at this one. Could this one be opposite to this one? No. Why? Because they meet at a point. Could this one be opposite to this one? No, because they meet at an edge or a side. So this face has no opposite face, which means this is the base of this cube. I will do exactly the same with the second drawing. I will start from the column that has 3 squares. So this one is opposite to this one. I have now 3 faces left. Could this one be opposite to this one? No. Could this one be opposite to this one? No, because they meet at a point and these two meet at a side, which means also this face is the base of this net because it is the only face that has no opposite faces. Let's look at the third net here. I don't have any 3 squares in the same column or in the same row. So where to start? If I look at the one in the middle, what do you notice about this one? This one cannot be opposite to this one and this one. Why? Because it meets this one at a point and it meets this one at a line. What about these two? This one, the one in the middle, cannot be opposite to this one because they meet at a point, and cannot be opposite to this one because they meet at a side. So the one in the middle also is the only face that has no opposite face. So this will be the base of the cube. Now look at this one. Where to start? I have a column here that has 3 faces. So this one is opposite to this one. What about the one in the middle? Look at this one. Could this one be opposite to this one? No, they meet at a point. Could this one be opposite to this one? Yes. But what about this one here? Look at this face here. Could it be opposite to the one up? No, because they meet at a side. Could it be opposite to this one here? No, because they meet at a point. Which means this face is the only face that has no opposite sides. Which means this will be the base of the cube without a lid. This is the end of our lesson today. Thank you for watching and see you soon.